In this example, we're going to be looking at two cumulative graphs that is put together on the same axis. So in any case, if you are worried that you might read wrongly, you can highlight it differently. So you can highlight different color just to make sure that you don't read from the wrong graph. Okay. So in this, for the two cumulative graph, right, we are looking at 120 students for two tests, English test and math test. So if the total is 120 students, okay, if I would like to find the median, the interquartile range, everything will be based on the 120 students. Okay, so if you want to, you can do a bit of prep work first, knowing that you will be asked for interquartile range and median. So if you would like the median, you will need 50% of the student. 50% of 120 will be the 60 students. So later on, we'll be using 60. 60 is not the median. So don't misinterpret. So the lower quartile will be 25% of 120, which is 30 students. So later on, we'll be using the 30 students. So you can do some prep work first to facilitate your calculation when it comes to two graphs. Because for these two cumulative graphs, we are looking at the same number of students. That means we'll be using the same number here. So the 75% percentile, which is the upper quartile, will be 90. Okay, so we'll be using the same number to get the interquartile range, median, of this. Okay, so let's start off with we start off with the interquartile first, which I need the upper quartile and the lower quartile. So I'm going to get the lower quartile first. So I'm going to get 30. So from here, I can get the lower quartile. So the lower quartile for English and also the lower quartile for math. Okay, so for English and math, my lower quartile. Okay, for English, the lower quartile is 30. For math, which is the yellow color, the lower quartile is 40. Okay, then I'll be using 90 to find the upper quartile. So 90 is here. So you just have to read directly across. So in fact, you can read off two values at the same time. Okay, so you just make sure you can identify correctly. Okay, so for math, the upper quartile is 62. For English, the green color one, the upper quartile is 74. So from here, I can work out the interquartile. So the interquartile for math will be 62 minus 40. Did I read wrongly? Okay. You read it from your own graph because I think mine a bit like my coloring a bit fat. So in case mine is affected by the thickness of the graph and my iPad pencil. Okay, you read it from your graph. Maybe your value is a little bit slightly different from mine. So for English, the interquartile will be 74 minus 30. 70 for English, it will be 74 minus 30. 74 minus 30 will be 34. Sorry, 44. So from here, I can also be reading the median. So the median will use the 60 students to read off directly. But they happen to have the same median. You realize that they happen to have the same median. So the median for both English and math are both 50 marks. Okay, so that is how you find the statistic when you got two graphs that's on the same axis. You can calculate the number of students first. Okay, then for part B, 1/3 of the students who took the math test passed the math test. So that 1/3 should be the top 1/3. So you can calculate 1/3 of 120 students. So that will be 40 students. So this should be the top 40 students. So you should count the 40 students. So this will be the top 40 students. So based on the top 40 students, you get the passing mark for math. Okay, math is yellow color, so make sure you touch the yellow color. So from here, you can see what the passing mark. So the passing mark is 48. Okay, so is it 48? 58. Oh yeah, I read wrongly, it's 58. Okay, this part here is 50. So I read wrongly, it should be 58 marks. So the passing mark will come from the top 40 students. Okay, so you got to interpret correctly. Okay, now the next part is we're going to be putting them, we're going to be commenting on the two test results. Okay, based on the answer of part A and part B, part 1 and part 2. That means, right, I got to make use of the interquartile, I got to make use of the median to comment. So the comment part is very similar to the mean and standard deviation. So I will usually do the statistic on a table. So for the median, we know that they got the same median. Then for the interquartile range, we know that for math, we got 22, and for English, we got 44. So if you base on the median, we couldn't tell any difference because both got the same median. So that means, right, based on the median, we will feel that students do equally well for math test and English test. So that is also a comment. So you can mention, right, since the median mark are the same, then students will fare equally well for both tests. So based on the median, I will feel that they fare equally well. So we cannot tell whether they are better in math test or English test. But if we talk about the interquartile, there seems to be quite a huge difference in the interquartile. English has a very wide spread between the top 75 and the lower 25. Math is the spread is like almost half. Okay, so what does the spread tells you? It is the same as your standard deviation. So if your interquartile range is very big, that means the students are actually not very consistent. So when the interquartile is very small, that means the students' marks is around the same. So they are actually more consistent. So again, I need to mention who is the one with the smaller interquartile range. So for math, the interquartile range is 22. Okay, I should say the obvious first. So the interquartile range for math which is the 22 marks, is smaller than the interquartile range for English. Okay, and that is the 44 marks. So the implication will be students are actually more consistent in their math result. So students are more consistent in the math test than English. Okay, so because the variety is very the difference between the top 75 and the bottom 25 is very small. In a way, it's quite competitive. Okay, so the fluctuation is smaller. Okay, so this is how you compare. The comparison is very much like mean and standard deviation. Okay, it's the same idea for mean and standard deviation. Okay, so this one, for this section, for example, it's a bit of a sketching. So I can roughly show you the sketch if you have a good idea about the highest mark, lowest mark, and the interquartile range. Okay, so we got to process this thing first. Okay, so there's a lot of information that help us to draw the cumulative graph. So first of all, we got 40 students here. 40 students and the highest mark is 100. So from here, I know that it will end off at here. Okay, and then we got 2 students who score more than 80 marks. So we got 2 students that score more than 80 marks. So the 2 students, right, will be the top 2 students here. This will be the 2 students. So these 2 students will be scoring more than the 80 marks. Okay, and then the lower quartile is 30. So how we get the lower quartile? Okay, we got 40 students. So the lower quartile will come from the 25%. So that will be 10 students. So from the 10 students, I got a lower quartile of 30. So 30 is here. Okay, and then of course we always start from 0, 0. Okay, and then the interquartile range is 20. So from here, I know that the upper quartile will be 30 plus 20. And the upper quartile will come from the 75%. So 75% will be the 30 students. So 30 students and 50. So with all the dots, I can join them to get a cumulative graph. So it will look something like this. Okay, so this one is just a bit of, if they want you to think backwards, they will have think something like this to make you think backwards of your lower quartile, upper quartile, interquartile range, all this. Okay, the more direct one is the one on example 3. So example 3 is the kind where you got 2 cumulative graph on the same axis, but the calculation for median interquartile range will still be the same. And the comparing and the commenting part is the same for mean and standard deviation. You always say the obvious, and then you say the implication based on the context. So in this context, we're comparing the math and English test. So example 4 is the work backwards idea that they might test you to see whether you can process the information backwards.